In this video, we'll be learning about cardinality of sets. So let's start off with this first problem. Write the cardinal value of the following set in symbolic form. And we have set G is equal to, and it has the elements pen, pencil, marker, highlighter, eraser, ruler, and compass. So the cardinal value is how many elements are in your set. It's the number of elements in your set. So for this problem, we just need to count how many elements are in our set, since our set is in front of us and it's clearly defined. So we have 1, 2, 3, 4, 5, 6, 7 elements in our set. So how do we write the cardinal value of that? So you write it as n, and then in parentheses the set name, which is G, and then is equal to the amount of elements in your set, which here it's 7. So it'd be n of G is equal to 7, and that's going to be your answer. So for the second problem, it says write the cardinal value of the following set in symbolic form. Set B contains a set of even prime numbers between 10 and 20. So here our set isn't listed out for us. It's not in roster method or set builder notation. It's just written out in words. So we have to write the set ourselves and then determine the cardinal value from there. So our elements in our set are going to be even prime numbers between 10 and 20. So even numbers are numbers that you can divide by 2. For example, if we divide 4 by 2, we're going to get 2 back. So 2 is a whole number, so when we get a whole number back, that means that the number is even. But if we get a non-whole number, then that means that the number is not even. So if we did 5 divided by 2, we're going to get 2.5, which that's not an even number, since it doesn't have a whole number as a result of that division. And a prime number is a number that you can divide by 2 numbers and get back a whole number. And these 2 numbers have to be different numbers. They can't be the same exact number. So for example, a number like 7, if we do 7, we can divide 7 by 1 and 7. And since it has only 2 factors and they're both different, that means that 7 is the prime number. So it has to have exactly 2 factors. It can't have less than 2 or greater than 2, exactly 2. So our set elements are going to be between 10 and 20. So that's not including 10 or 20. So we're going to start at 11. Is 11 an even number? If we divide 11 by 2, we're going to get 5.5, which that's not in a whole number. So that means that 11 is not even. And then we go to 12. We know that 12 is even because 12 divided by 2 is going to give you 6. But is 12 a prime number? Well, we can do 1 and 12, but if we break down 12 some more, we're going to get 3 times 4. So notice that we have 1, 2, 3, 4 different factors. So therefore 12 is not a prime number. Now if we move to 13, we know that 13 is not even. And we can move to 14. 14, we have 1 times 14, but 14 can break into 2 times 7, which that's 4 different factors. So 14 is not a prime number. 15 is not even, so we move to 16. We have 1 times 16, and 16 we can break into 2 times 8 or 4 times 4, so 16 is not a prime number. We can move to 17, but 17 is not even. We can move to 18, but 18 we can break 18 into 2 times 9 or 3 times 6. So 18 is not a prime number. And then our last number is 19, but 19 is not even. So we have no elements in the set. If we had to write the set, it would be B is equal to, and then we have nothing inside of our brackets here because we have no elements in our set. So how do we write this for the cardinal value? Well, the cardinal value is going to be 0 since there's nothing in our set. So we write it as n, and then in parentheses, capital B is equal to 0. And that's going to be your answer. So for this third problem, it says write the cardinal value of the following set in symbolic form. Write the set H as the set of even prime numbers less than 2. So our elements are going to be even prime numbers less than 2. Now, something to note is prime numbers can only be positive. There's no such thing as a negative prime number. So if our smallest possible prime number is 0 and our biggest number is 1 because it has to be less than 2, so 0 and 1 are our only 2 possible elements in the set. Now we know that 1 is not even, so we can get rid of 1. So our only element left in our set is 0, because 0 is even. If you divide 0 by 2, you're going to get a whole number back. You're going to get 0. So we just have to find out if 0 is a prime number. Now, remember, a prime number is a number that has two different factors that you can divide it by. So we can divide 0 by 1 and we'll get 0 back. But we can also divide 0 by 2. We can divide 0 by 3. We can divide 0 by 4. We can divide 0 by 5, and so on. So there's more than two different factors. So this means that 0 is not a prime number. So again, we have a set with no elements, an empty set. So set H, we can write it as this. We can just use the close and open brackets with nothing in between them. You can also write set H as the null notation, which just means nothing is in the set. So how do we write the cardinal value? So we do in, and then in parentheses, our set name, which is H, and then the cardinal value. So since we have nothing in between here, we just write the cardinal value to be 0, and that's going to be your answer. So for this fourth problem, it says write the cardinal value of the following set in symbolic form. So we have set A is equal to, and it has the elements A, B, C, and then an ellipsis, which just means it moves all the way to Z. So we can notice a pattern. It's saying the letters in the alphabet. So you can list the alphabet one by one. You can count and say A, B, C, D, and then all the way till Z. Or you might remember all the letters in the alphabet. How many are there? So there is 26 letters in the alphabet. So we can write that as the cardinal value. We can say in, and then in parentheses of the set name, which is A, is equal to 26, because there's 26 letters in the alphabet. And it's moving from A all the way till Z. So that's going to be your answer. So for this fifth problem, it says write the cardinal value of the following set in symbolic form. So we have set Q is equal to Mercury, Venus, Earth, Mars, Jupiter, and Saturn. So here the element is in roster method, so we are able to count it out. So we have 1, 2, 3, 4, 5, 6. So there's 6 elements in this set, so that means that the cardinal value is 6. So we write it as in, and then in parentheses of the set name, which is Q, is equal to 6. And that's going to be your answer. So for the sixth problem, it says write the cardinal value of the following set in symbolic form. Set V is equal to cheddar, mozzarella, Gouda, brie, feta, and parmesan. So here we have our element in roster method, so we can count it out to get the cardinal value. So we have 1, 2, 3, 4, 5, 6. So we have 6 elements in our set. So our cardinal value is going to be in, and then in parentheses, the set name, which is V, is equal to 6. And that's going to be your answer. So for the seventh problem, it says write the cardinal value of the following set in symbolic form. So we have set in is equal to null notation, or null. So remember, whenever we have null notation, this just means there's no elements in our set. It's an empty set. So since we know that there's no elements in our set, we know that the cardinal value is going to be 0. So we can write it as n, and then our set name, which is capital N, is equal to 0. And that's going to be your answer. So for this eighth problem, it says write the cardinal value of the following set in symbolic form. Set D is equal to 10, 12, 14, and then goes on to 30. If you notice, there's a pattern here. It starts at 10 and then it goes up 2, or just added 2 to the number, and it keeps on repeating. It just keeps on adding 2. Or you can say that it starts at 10 and then reports even numbers all the way up till 30. However you decide to look at it. So we notice that we can see that pattern. So we need to write out all the numbers in that set, because this ellipsis is just simplifying the set. So we need to expand it. So we have 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and then finally 30. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 elements in our set. So our cardinal value is going to be 11. So it's going to be n of the set name, which is D, is equal to 11. And that's going to be your answer. So for this ninth problem, it says write the cardinal value of the following set in symbolic form. Set H is equal to 1/10, and then 2/10, and then 3/10, and then it goes on to 10/10. Now, you can see that it has a pattern. The numerator starts at 1, and then it adds 1, and then it adds 1 to the previous number, and then so on. Or it just counts. It goes 1, 2, 3, and then all the way up till 10. So we can write out that set. Or we can see that it starts at 1, which that would be our first element we see, and then 2, and then 3. But if you notice, this number that we're counting right here on the bottom matches this number on the top. So we can just look at the last piece, which is 10/10, and notice that it just counts to 10. So there's 10 elements in our set, which is true. So we can write the cardinal value of this set as n of h is equal to 10. And that's going to be your answer. So for this 10th problem, it says write the cardinal value of the following set in symbolic form. So we have set H is equal to empty set. So since it has no elements in the set, we know that the cardinal value of that is 0. There's nothing in between those braces right there. So we can say that n of E is equal to 0. And that's going to be your answer. So for this 11th problem, it says write the cardinal value of the following set in symbolic form. N is equal to, and then we have our variable to represent each element in our set, which is n squared. And then we have our condition. N is an element of, and then we have natural numbers. So this weird looking n right here, it looks something like that. That means that it's natural numbers. So you might ask yourself, what are natural numbers? So natural numbers are positive counting numbers, or just positive whole numbers. So for example, 1, 7, 29, 81, and so on are a part of natural numbers. Now if you notice, positive whole numbers can go all the way to infinity. Notice how I can keep counting up. I can go to 127,000, and I can keep going to bigger and bigger positive numbers. So you can notice that natural numbers are infinite. So if all n has to be is an element of natural numbers, it can be an infinite amount, since natural numbers are infinite. So how do we write the cardinal value of that? Well, there's this notation that represents all of the natural numbers. There's a special notation for this. It's called Aleph Null, which it's written like this. Now this is just a rough sketch, so you might have to Google it. It's kind of like an N, and it has a subscript, which is just 0. And this represents the cardinality of a set for natural numbers. So anytime you have a set containing all natural numbers, this would be the cardinal value for it. So we can write the answer as n of our set name, which is capital N, is equal to, and then we have Aleph Null. So that is going to be your answer. So for this 12th problem, it says write the cardinal value of the following set in symbolic form. So we have set T is equal to, and we have our variable to represent each element in our set, and then we have a condition. N is an element of natural numbers. So we've done the problem before. Anytime you have a complete set of natural numbers, which this is what it is here, it's saying n is an element of natural numbers. Well, n can be any number in the set of natural numbers. So that means n has an infinite amount it can be. So since we know that it's an infinite amount of natural numbers, we can use that Aleph Null notation. That was a bad start. Let's try it again. So it looks something like this. And then remember, we have a subscript of 0. And then we have n of our set name, which is capital T, is equal to a left null. So that's going to be your answer. So for this 13th problem, it says write the cardinal value of the following set in symbolic form. So we have set M is equal to P, Q, R, all the way till Z. So our elements in roster method, so we need to list this all out. So we have P, Q, R, S, T, U, V, W, X, Y, and then Z. So we need to count our elements in this set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 elements in our set. So our cardinal value for that set is going to be 11. So we have n of the set name, which is capital M, is equal to 11. And that's going to be your answer. So for this 14th problem, it says write the cardinal value of the following set in symbolic form. The set of numbers on a standard 10-sided die. So our elements in our set are going to be numbers on a standard 10-sided die. So if a die, which just means a single version of dice, it's going to have 10 different sides, that means that there's 10 possible numbers it could land on. So since we know that, we know the cardinal value is 10, but we have no set name to represent this. We usually write n and then in parentheses of a name. But here we don't have the set name, so how do we represent that? If you don't know the set name, you can represent the cardinal value of that set as the absolute value, just have the brackets, and then write the cardinal value in between those brackets. So here it's 10, so the cardinal value would be written like this, absolute value of 10, or just absolute value brackets and then 10 in between those. So that's going to be your answer.